Hello, my name is Micah Schultz. This is my DSARI assignment on home energy audit. So a little background on where I did my energy audit at. I did at the Quad on Delaware, which is an apartment complex in Stadium Village. It's a two-person unit with 2 bedrooms and 2 bathrooms, and I share it with a friend. The total square footage is 806. Some EIA information on Midwest Apartments calculates the average consumption of energy based on square feet. That was found to be about 42.7 thousand BTU per square foot for an urban Minneapolis, Minnesota apartment complex with over 5 units. So we multiply that number times our total square footage, and that gives us the total BTUs. And we can convert that to kilowatt hours, which gives us a total of 10,086.4 kilowatt hours. So here's a little breakdown of the biggest energy consumer in a house. So about 50% is heating and cooling. Then you have your water heater, your lighting, your washer and dryer, your refrigerator, and your other appliances and electronics. And obviously these values and percentages change for everybody based on how much you use one of these things. So the 8 devices that I decided to test were my computer, a wireless charger, an LED light strip, a lamp, a microwave, my fish tank filtering system, and I wanted to see the difference between my big monitor and my small monitor when it comes to energy consumption. So here's the weekly breakdown of all my devices. The computer was on 24/7 and it was variable power. The wireless charger takes about 2 hours to charge my phone. I charge it maybe 1 or 2 times a day, so the average was about 2.71 hours a day. The LED light strip was on 24/7 until the weekend when I turn it off, so that averaged about 16.35 hours. The lamp was on when we were in the living room, which was about 3.5 hours a day. The microwave was only used to reheat things, so it was about 0.0446 hours a day. The fish tank was always on 24/7 to keep my tank clean. The big monitor and the small monitor were connected to the same computer, and they were both used the same amount of time as each other, which was about 11.97 hours per day. So from this breakdown we can see that the computer by far had the most energy consumption. It was about 143 watts average when it was on, and 102.96 kilowatt hours per month, which is way more than any of the other devices I tested. As you can see, the wireless charge is about 1.7, LED light strip was 3.2, lamp was 2.55, microwave was about 2.58, the fish tank was 5.18, and then the big monitor was 13.14, while the small monitor was only 4.23. And you can see the big difference there that pixels make and the size of the screen when it comes to energy consumption. So comparing the results, the biggest energy user by far was the computer, followed by then the big monitor. The calculated energy for the year was 1,628.24 kilowatt hours per year for just those 8 devices, which is considerably less than the average of 10,086. The reasons for this was because obviously we only tested 8 devices, and we did not test the biggest energy users such as the heating and cooling or the washer and dryer, and the values were average. They were not exact timestamps for every day of the whole entire year. So analysis in future, even though only 8 devices were tested, there are still some ways to save power. One thing to think about when you're doing an audit is the age and construction of the apartment complex or house that you're doing it in, as that will lead to changes in energy efficiency. Phantom power, which is the power that a device takes when it's plugged in but not in use. The wireless charger had a lot of phantom power. It actually used more energy when it was not charging my phone than when it was charging my phone. So some ways to improve: unplug devices when not used. That will cut out the phantom power. I should start doing that for my wireless charger, and I should look for more efficient options. One note about my computer is that I have a bronze power supply. There are better tiers for energy efficient battery supplies for computers, so you could upgrade and get some more efficiency there. Here's some more pictures of the project and my references. Thank you.